Hey everyone, Mr. Hayden here. Initially we made two tabs in our saving spreadsheets. One for solving for B when you make a one-time deposit with a certain interest rate compounded at a certain frequency, and then another tab when you were which you were also solving for B, where you were making a regular deposit every so often at a frequency of n times a year and at a specific interest rate. Um, so now we're going to add two sheets for how to that will compute P, or the principal, given instead of given P computing B, uh, we're given B and computing P. The other day for block 6, um, uh, we had an in-class exercise where we were rewriting the equations, the compound interest formulas, and solving for P instead of B. So the formulas that we ended up with are right here on the left-hand side for both the one-time deposit and the regular deposits. So we're going to duplicate the spreadsheets that we have and then just change two formulas, two cells, and we'll then have a spreadsheet where instead of solving for B, you're solving for P. Which is convenient if you know in the future how much money you'll need, and then P is how much money you invest now or how much money you put in every, every so often, and you can solve for what you need to reach a goal. So I'm going to start. I'll do the one-time deposit one first. So I'm going to duplicate the one-time deposit tab. Well, actually, before I do that, um, let's rename them so that we are clear of what each spreadsheet is solving for. So for the first one, the one that we already did, the ones that we've already done, I should say, we were solving for P. I'm sorry, we were solving for B. Why did I just change it to P? So let me do B. And then on the regular deposits one, we were also solve for B. So those are the first two that we did. Now we're going to solve for P instead. So I'm going to duplicate the one-time deposit one because we're going to do that one first. And then I'm going to, let's see, I'm going to change its name and call it solve for P. So we'll call it one-time deposit solve for P as in principal. Okay, so now instead of the user entering how much money they're going to deposit, let's see, do I not have a header there for B? I guess let's do deposit B. Okay, actually we start off with P. There we go. Okay, so now we need everything the same except that there's going to be a formula for P, and instead of B being computed, the user is going to enter a value for B. So let me change, just to make it clear, I'm going to change the background of the image that they enter a value in to yellow, and then the deposit P is going to be computed. So let me change that back to green. Okay, so now they enter N, T, R, and B, and P is going to be computed. So let's see if we can, first of all, I'm going to get rid of the formula for B, and I'm just going to enter a value like any dollar figure. Okay, so now I go up to P, the P cell, and I need to enter the formula. So let's see, we're on the one-time deposit, so it's this one right here. So I'm going to enter equals B. Now what's B? B is B6. So it's going to be B6 divided by, and then 1 plus r over n to the nt. So that would be 1 plus, okay, r is B4 divided by n. N is B2, and then exponent symbol, and then I need to do n times t. So n is B2, and t is B3. All right, then I press equals, and there you go. For over 4 years, interest compounded 12 times a year, monthly. If I start off with, to reach $5,000 at the end, I need to start off with 4,765.70 and 78 cents. So let's go and let's enter this value over on the other spreadsheet. So what was it again? It was 4,000. The value came 4765.78. So if I do 4765.78, I should see $5,000 at the end of B years. So yeah, so everything else stays the same. The same amortization chart is computed at the bottom, the same interest earned. It's just that the user is now entering B and it's computing P, whereas on the first one, they enter P and it computes B. But essentially, it's the same transaction. You're just solving for a different variable in the formula. Okay, so now let's do the one-time deposit one, which has the slightly longer formula. Okay, so for the one-time deposit one, let me, or the regular deposit one, I should say, not one-time deposit. I'm going to duplicate the one that I have, and I'm going to rename it so it's regular deposit solve for P instead of solving for B. So solve for P. Okay, so now the user types in B. So let me change that over to yellow, and then P is going to be computed. They don't enter P, it's computed for them. And P for regular deposits is how much money they have to deposit every month. So let's go and look at our formula for B. So B, let's see, is going to be, and so it kind of looks a little bit nasty, but let's see if we can do it. So it's going to be P, the principal, and the principal is, so I'm typing equals, the principal is B1, and then times, and then it would be, actually no, I'm sorry, we're solving for, let's see, we're solving for P. So it's the first formula that I want. Okay, so it's B times n over r to the 1 plus r over n to the nt minus 1. Okay, so here, let's go back to this. Okay, so so I'm solving for P. So up here on the top in B1 is where my formula is going to go because this is what I'm trying to enter. So I'm going to put an equal sign, and then B is B6, okay, times n over r. So I'm going to do parentheses n. N is 12, or B2 divided by R. R is going to be B4. Okay, and all of that, I'm going to put another set of parentheses around that whole thing. So B6 times B2 divided by B4 is my numerator, and then my denominator is going to be 1 plus R over N to the NT minus 1. So I'm going to enter it just like it appears in the formula. I'm going to do two parentheses, and then it's 1 plus R. R is B4 divided by N. N is B2, close parenthesis, raised to the power, so the caret symbol, and then it would be NT. So N is B2 times T. T is B3. Okay, so, and then minus 1. Okay, and if I did this right, hopefully I'm going to get the expected result. No, I'm not. Let's see, what am I missing here? B6 times 1 plus... and let's see, what does it say? Circular dependency detected. B6 times N divided by B4. Yeah, that's it. Divided by 1 plus B4 over N T minus 1. All right, I'm going to pause the video while I figure out what's wrong with my formula. All right, I'm back. So it turns out the problem wasn't my spreadsheet. The problem was I actually had the slightly wrong formula for P. Embarrassed to say. Right here in the numerator, instead of it being N over R, it should be R over N. So I'm going to change that, and it's going to be in my formula, instead of B2 divided by B4, it's going to be B4 divided by B2. And then let's see if we get something right there. Okay, so it looks like we have something that's correct. Okay, so now I have a deposit of $40 every month for 10 years is going to end up with $5,000 at 1.2% interest rate, which makes sense because that's saving about $500 a year. 40 times 12 is 480, or about 500. For 10 years would give you about $5,000, which is what it does. Okay, so now we have the two spreadsheets that we can do the new homework assignments for. All right,